Hello everybody, this is the notes for advanced geometry section 5.2. We talk about perpendicular bisectors, and the name of them is just what they are. All right, a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. So it's an object going through a midpoint perpendicular to a segment, perpendicular bisector. So it has some properties. All right. Point D right here is the midpoint. If I move point A around, you can see D is staying right in the middle between A and B. Now, it is also perpendicular. No matter where I move point A or move point B, we're keeping that a 90-degree angle. So this line that I just highlighted here, that is perpendicular, it's going through the midpoint. It is a perpendicular bisector. So the property is, if you put a point anywhere on that perpendicular bisector, that's this point C. Keep an eye on those measurements, AC and BC. Anywhere where I move that point on the perpendicular bisector, it is staying the same distance away from A and B, the endpoints of that segment. If I go the other direction, ignore that big arc there at point D. That's just a programming issue. Still a 90-degree angle. But AC and BC, they're the same. Doesn't matter where I put it. All right, so this is the property of a perpendicular bisector. Any point on a perpendicular bisector is equidistant from the endpoints of the segment. All right, and actually I got to move that. Whoa, what is that? There we go. So just to get to this drawing here, I got segment AB. I constructed this so that this line here is perpendicular at the midpoint. So this property says it's a perpendicular bisector's theorem. Says that you put a point anywhere on that perpendicular bisector, point C, it is the same distance away from the endpoints. So that AC equals BC. Okay, that's the biggest thing here. So now, some examples that deal with this. Question number 2 here. Point B, it is on this line, it's perpendicular here. My board's not writing properly here. It's perpendicular there, it's going through the midpoint. And so DB is a perpendicular bisector, which means AB and CB are the same. And so 7x minus 16 has to equal the 3x plus 8. And then it's just normal algebra to solve. But because point B is on that perpendicular bisector, it's the same distance away from A and C. So 4x, subtracting 3x from both sides, add 16, we get 24. X is 6. All right, the next question, number 3 here. We don't really know anything about BA and BC, but it is on, point B is on that perpendicular bisector. Okay, we got perpendicular here, we got those two segments equal, CE and AE. So this line, BE or BD, whatever you want to call it, it's a perpendicular bisector. It's going through the midpoint of CA and it's perpendicular. So the same setup. 6x plus 11 equals 11x minus 9, and you can solve it the same way. Okay. For this example, there's not much more to it. It's just there's more information in the picture, but you just got to sort your way through this stuff. So, reading the directions, it says, use the diagram. EH is the perpendicular bisector of segment DF. All right, with it being a perpendicular bisector, you know those two segments are equal to each other. Let's find the indicated measure. So we got some x's and y's in here. What we're going to do is just off to the side, we know FE and DE are the same. So 7x plus 9 equals 9x minus 1. That gives me a 2x equals 10. X is 5. So it's not our answer. The question wants to know segment lengths, but we need the x value. Now up here, we're given some y values. We're told segment FG and DG are congruent to each other. Those both contain the variable for y. So 7y plus 8 will equal 10y minus 4. Subtract 7y from both sides, add 4 to both sides. We get a y value of 4. Again, not our answer, but we need the information. So, to find all these segments, now that we know the x and y values, we can just start plugging them in and getting our side lengths. But there are some things to make it easier. You know those two segments are equal to each other. So FG and GD are equal to each other. You know ED and EF are congruent to each other. EH was a perpendicular bisector. So that means FH and HD are going to be congruent to each other. And so once you know one of those things, you know multiple other sides. All right? Okay, and so we can just start plugging the things in. If x is 5, looking at segment EF, we got 7 times 5, which is 35 plus 9, 44. So that means ED is 44 also. FH is this 3x plus 4y. So if x is 5, that's going to be 15 plus 16. So that means this is 31, which means HD is 31, which means FD is going to be 62. Okay, we got all the side lengths. Once we know x and y, we can figure them out. All right, this is the last thing. This is what I'm going to leave you with to think about, and hopefully you'll come up with some ideas on your own for tomorrow in class. If you are given 3 non-collinear points, is it possible to draw a circle that contains those 3 points? So basically, you're just given 3 points. Doesn't matter where they are. Can you draw a circle containing those 3 points? If it is possible, where is the center of the circle? Okay. In these notes, I've given you all the information you need. You just need to interpret it. So try to think about this, come up with some ideas. We'll mess with it in class tomorrow, but try something on your own. And like I asked you in class, if you have your own compass, would you please bring it to school tomorrow? Have a good night.